If you look at robotic assembly of structures in space, right now, there's not a whole lot being done. But if you look 5 to 10 years from now, I think it's going to be a huge field to be able to assemble structures in space robotically. My name is Dr. Harold Hess. I'm CEO and co-founder of Enduralock. I had an interesting road to get here. I originally invented a spinal implant. My background is actually I'm a neurosurgeon by training. So I invented a spinal implant. FDA required that it survive 5 million cycles of compression and 5 million of torque without loosening. So I had to come up with a lock. I realized, however, that this locking technology, and this was months later, could have many industrial applications. So I kept the IP separate, licensed it back to the spine company at a one-time nominal rate, and then put the IP into this company and started this company. And then over a number of years, developed the technology and also developed numerous other technologies after hiring a team of engineers.
Wow. So the company's name is Enduralock, and it is a really fascinating story how you got to where you are today. I was reading the case study. This is not your typical space story, and I love that. This is exactly the kind of innovation that I think the space sector is really looking for, and you all are a shining example of that. Can you tell me a bit more about Enduralock and what you all are developing?
Sure. At its core, we are fasteners and connectors. Now, what that means is, on the one hand, we have actual fasteners, meaning mechanically locking high vibration resistant bolts or nuts that are reversible and reusable with a standard hex socket. Unique thing about them is that they remain locked even with loss of preload or clamping force. That latter attribute actually makes them ideal for a space environment where you can have cyclical thermal extremes that cause bolt elongation or bolt contraction, and that causes loss of preload, and most joints will therefore fall apart. And for that reason, most fasteners going into space are safety wired, which is very labor intensive. Mechanic typically safety wires 10 to 15 fasteners per hour. What we have done is to make it simplified so that you just have to apply a socket to put it on or take it off. And in that same hour, we could put in over 300 fasteners. So dramatic time savings and therefore cost savings. Another technology we developed is the only self-aligning nut plate. But think of it like the female end of the assembly. And with current nut plates, the nut element cannot tip. So if the bolt is coming in a little bit from an angle, it'll cross thread. With ours, you can be 20 to 30 degrees off angle and it will engage, and then it tends to self-align during tightening. It can result in a dramatic time savings for aircraft maintenance and assembly. If you think leading edge of the wing, trailing edge of the wing, you're going to have curved structures with hole mismatch. You might have 100 bolts to apply, get up to number 60, cross thread, now you got to take the whole panel off and start over. But it also has a lot of applications for space when we start looking at robotic assembly. With current technology, the bolt might not come in perfectly in line with the nut element. So if it's off a few degrees with current technology, you'll cross thread. With our nut plates, however, it will engage, and therefore it allows for robotic assembly in space. Just another technology that we've developed. We're also working on a satellite docking connector. We developed a nut plate that allows for non-parallel surfaces to be clamped up and have full bearing surface, in other words, full strength. Developed the first mechanically locking nut plate. Every nut plate relies on friction of the threads. This nut plate actually has teeth that engage teeth so that it mechanically locks. So it would be for extreme vibration environments such as hypersonic applications as well as reentry vehicles. And then most recently, we also applied the technology to a mechanically locking high vibration resistant electrical connector that's easily reversible and reusable and is toolless, as well as we have a project going on right now for a mechanically locking high vibration resistant fluid connector. It could be either hydraulic connector, and this specific project is for the B-2 stealth bomber. Also could be a fuel line connector for launch vehicles. So a number of different technologies have developed or are working on currently.
I'm wondering, especially in the realm of space application, when did it become apparent to you that many of the things that you were developing would be useful in a space context?
We've been very successful with obtaining SBIRs, Small Business Innovation Research. Since 21, we've gotten 5 phase ones, 5 phase twos, and we currently have a TACFI. One of those was to miniaturize the fastener down to a number 4, which is 3 millimeters in diameter. And we we're awarded that with our TPOC being under AFRL-RV. So in other words, the Space Vehicle Directorate of AFRL. That's where we started getting more interest for developing these technologies specifically for space use. And then in a phase 2, we developed a prototype for an end effector for robotic assembly of structures in space using our fasteners and nut plates. And we currently have a TACFI under Delta 45 Space Force as well as AFRL-RV, where are developing a magazine to store the fasteners prior to actual deployment in space. And again, our fasteners are reversible and reusable, so the magazine can also function to store the fasteners after removal if you're going to repurpose the structure in space.
I'm trying to keep in context also here. There's a fascinating alignment where your company and SpaceCom had sort of a right time, right place situation. Can you tell me a little bit about that, about how I've been using the word alignment a lot. It sort of feels like it makes sense when we're talking about fasteners.
I honestly don't remember exactly how we found out about SpaceCom. It probably was through Rich Hodge. And it was a few years ago, we were informed about SpaceCom. And at the time, it was a much smaller show. And they had a special area for startups. You had a reduced cost and, a little bit smaller booth, but, reduced cost. And I remember Rich and others bringing representatives of various primes over to the startup section so that they could see what startups are trying to do, we being one of them. If I recall correctly, it was also around that time, I remember it was 2018, that we won a NASA competition. We were able to promote that as well, kind of get our foot in the door, like I said, at a smaller show at a much reduced cost versus some other shows that are focused on space.
Tell me a bit about maybe how the last few years have gone for you all, maybe a look ahead at what's coming next for you. Do you still consider yourselves a startup?
Well, there are all definitions of a startup. I'll give you a classic example that happened to us. A few years ago, we were also focused on oil and gas applications.
Mm-hmm.
So we had projects prior to the virus with Halliburton, with National Oilwell Varco, with Superior Energy. When the virus happened, unfortunately, oil and gas tanked. Aerospace also went down. I mean, if you look at it, there's still not been a new platform for Boeing or Airbus as far as commercial aircraft. The reason I brought that story up, a couple of years ago, we were a finalist for Oil and Gas Startup of the Year at the Abu Dhabi International Petroleum Exposition Conference, which is the largest oil and gas show in the world. And so we were one of 3. We did not win, but I will say that the other 2 were multinational companies with revenues in the billions. And they were listed as startup for the simple reason that they were multinationals focused on other things than oil and gas and had entered the oil and gas industry. So yes, they were a startup to oil and gas, but they had, a few thousand people working for them and were, essentially on multiple continents. Well,
That is a creative definition of a startup for sure.
right.
Fair enough.
With that in mind, I guess, in a sense, we're a startup or we're early stage would be another way of looking at it. As far as where we want to go, I mean, obviously, we have a lot of products that could be used for aircraft. And we are going to be on a new helicopter platform when it comes out. Listed to be on that platform. We're waiting for a commercial aerospace, aircraft platform to come out. We've had interest from the primes, for use of our products. But I think a big focus of our company is going to be on space. If you look at robotic assembly of structures in space, right now, there's not a whole lot being done. But if you look 5 to 10 years from now, I think it's going to be a huge field to be able to assemble structures in space robotically. And when I say robotically, yes, we have the technology for being able to do that. But what I would like to do as a next step is adapt our system to an intelligent vision-based system so we can make the entire process autonomous, so that you can send basically a robotic vehicle out in space somewhere and have it assemble structures without any human intervention in preparation for humans arriving at a future point. If you look at, not only at the moon, but you look at Mars, I mean, I think that's where this is going to really become essential. And if you look at fasteners currently, we are the only fastener or have the only fastener that is ideal for a space environment and can be inserted robotically in space. Most things going into space, they're all safety wired. You cannot safety wire in space. A robot can't do it. So we have a unique position, I believe, for our company. The other focus is we're developing a satellite docking connector. And I know there are a few companies out there that have or are developing satellite docking connectors, but I think ours is unique in the sense that it offers a mechanical linkage sufficient for in-space transport, data and power connections, and refueling all in one connector. So not only can we eventually refuel a satellite, but we can also upgrade the satellite. If you have a satellite that incorporates our technology on orbit, then we could incorporate the other half of our connector on an ESPA or ESPA Grande class, incorporate new sensors, new electronics, fly it up there. Not only do you refuel the existing satellite, but you refresh the satellite at a much reduced cost than sending a whole, another large satellite up into space.
What's so fascinating about what you're talking to me about is that this is the technology that when we talk about the future tech and also, as you said, the next 5 to 10 years of ISAM and the like, this is the kind of technology that really will enable a lot of that. And I don't think it gets its time in the sun that it should. I think a lot of people forget that this is really the kind of technology that will enable a lot of what the big picture dreaming is about. And it's so cool to hear about these innovations and also what your company is doing. So
Not only are you talking with ISIM as far as servicing of satellites, but you can get to the point where you can build satellites on orbit or build space vehicles on orbit using our fastener technology as well as our connector technology.
it's really cool living in the future. And it's just so neat hearing about these kinds of technologies. Dr. Hess, it's been really lovely speaking with you. Thank you for taking the time to walk me through your incredible journey and also the journey of your company. I wish you continued success, and hopefully I will see you in Florida later this month.
All right, that sounds great. I look forward to meeting you.